Hello everyone, I'm Dennis Flower, former editor of leading industry publications, and now working with SFG20 to support its 2024 virtual summit, which will take place on 20th of November. And it's designed to provide a wide range of advice on the highly important topic of future-proofing buildings. And so for today's exercise, I'd like to say a big thank you and hi to Chris Wollen, chairman of Ergro. Hi, Chris.
Hi, Dennis. How are you?
Thank you so much for agreeing to be interviewed on the topic of the reality of reducing carbon emissions in buildings.
You're more than welcome.
So, can I ask the first question? What are the easy wins to decarbonising a building or improving its energy rating?
Since the introduction of the MEES regulations, the immediate focus for landlords on achieving EPC by 2028 has obviously put a real focus on what you need to do to try and improve it, and to do that as quickly as you can. Obviously, we've also got UK net zero by 2050. Key to this is thermal modelling of the building. So you assess where the heat gains and heat losses are, and try and tackle those bigger heat losses and gains first. Things such as building fabric, double glazed windows, improving insulation to walls and roofs, because they are big heat loss and gain areas. Removing gas-fired appliances to form decarbonisation, and gas-fired heaters. Upgrading LED lighting, upgrade to LED lighting, installing PV panels to obviously capture the sun. And what we have been carrying out quite a lot as a business is changing belt-driven fans, old-style belt-driven fans, to direct drive EC fans. We're seeing quite significant savings on that conversion, and it can be carried out quite easily on retrofitting into existing facilities.
Fantastic. Thank you, Chris. We're off to a great start. So, second question. What are the issues when trying to decarbonise a building or improve its energy rating?
From our experience, what we're finding is a lot of these buildings are occupied. So you're having to carry out quite substantial work within an occupied premises. So upgrading insulation to walls, or replacing windows, or replacing infrastructure is quite intensive. So it's an issue. It can be overcome, but there may be some sort of swing space that people need to use to move people in that area whilst the works are being carried out. Planning permission, especially on listed buildings, where there's either the fabric's changing, so you're changing the internal or external appearance, or you need external space for heat pumps and PV. That is proving quite difficult, although the planners are now becoming more open to allowing this work to take place. There's been some forums, some of our existing clients have held some forums and group sessions where they've had the planners, the project managers, the sustainability teams all around the table to try and work a plan forward to make it actually more palatable. The internal infrastructure of a building generally can't cope with the standard type heat pump. So it has to be replaced in its entirety, or you install electric boilers or high temperature heat pumps that are just not as efficient. It still ticks the decarbonisation box, but they're just not as energy efficient.
Fantastic. Thank you, Chris. This is I'm loving this. This is making so much sense to me. So third question. What are the common high energy use services within a building?
It tends to be things like fans, air handling units, lighting, boilers, the air conditioning, chillers and split systems. When they're running, when they're not actually required, so outside of time zones, when the buildings are occupied, or they're fighting each other. That tends to be the higher usage within the building.
Thanks for that. Another question. What can be done to reduce the energy consumption of a building?
One of the key things is regular maintenance of the M&E services within the building. Things such as block filters and dirty coils. increase the fan running amps due to the increased work that it's doing. So if you can keep on top of your PPM on fan control maintenance and filter changing, that's very, very critical. Same goes for the water quality in the heating and cooling circuits. If you've got high levels of solids in that circuit, it reduces the heat transfer from the coils, which means you're using more energy to try and get the same output. The other thing is to review how, or when and how you're operating the plant, looking at temperature set points, time schedules, speeds, occupancy levels, etc., because they're all key to reducing the energy consumption. We offer as a business a solution called intelligent monitoring. We fit sensors to key parts of equipment and plant and pipework to monitor the heating and cooling's on. So we've got live data where we see that we've got hot water going through pipes, chilled water going through pipes. Airflow measurements are all monitored by the system, and it all sits on its own network. We then produce off the back of the data that we receive from that, from those sensors. We produce a monthly report highlighting where the equipment's running unnecessarily, or too hot or too cold. So, for instance, if you've got the chillers and boilers running at the same time, we would then look into why that is happening. Does it need to happen? If it doesn't, then okay, let's alter the controls to suit. Same with fans. After buildings occupations is finished, air handling units running all night, fans running all night, extract fans, that sort of thing is quick wins for energy saving within the building. We can also give clients 24/7 access to the live system when required, and because it's standalone technology, it doesn't have to rely on an existing BMS or control system. It just gives you a factual count of what's going on with the system at any given time. The enhancement of that as well, you can link it to occupancy sensors to monitor frequency of use of toilets, office floor plates, and then that information can be fed back to cleaning contractors by the client so that they can then reduce the amount of visits in low density areas. And obviously there's a cost saving to that, but also an energy saving through the impact of those people going into those spaces.
Fantastic. Thank you so much, Chris. So final question, I think, and can you explain after this excellent description of everything that's going on in the industry, can you explain what Ergro are doing as a business to achieve net zero?
So we made a commitment to net zero with our Ergro Earth net zero plan. As a service-based business with engineers out on the road doing service and maintenance and project work, we've got a large fleet of vehicles. So we decided to tackle that first because that's one of our key mission items. So in 2014, we trialled electric vans. We had some Nissan NV200s on the fleet. And you imagine back in 2014, the infrastructure was even worse than what it is now for electrical charging. So we trialled that with our engineers. We've maintained some of the electric vehicles within the fleet, but we also then looked at going over to hybrid vans, whereas there's a lot of hybrid cars on the road, but actually hybrid vans, there's very few. And in 2020, we took delivery of a fleet of hybrid transit customers, and we've still got those on the fleet now, on a newer version, because we change our vans every 3 years to keep up with the technology and the latest reduction in emissions. And we've achieved zero diesel fleet by 2023 last year. So all of our fleet now consists of either electric vans, plug-in hybrid, or petrol. So we have no diesel on the fleet anymore. This year, we've recruited a sustainability manager. He's been reviewing our scope 1, 2, and 3 emissions and looking at where we as a business can reduce our emissions and also help our clients reduce their emissions as well. Our plan and target is for ISO 50001 by mid-2025 and as a business to be net zero by 2035.
Amazing. Well, I'm sure you're well on the way to net zero, Chris. Fantastic example to the industry. I'm sure that many people will be following your example in the near future too. Chris Wollen, thank you very much.
Thank you very much.